Welcome to the Explainer. So today we're diving into a really fascinating new paper about giving AI something it's never really had, a perfect memory. You know, a cheat sheet, basically. And let me tell you, the results were not at all what the researchers, or really anyone, expected. So let's start with this question, because it really gets to the heart of a weird limitation in today's AI. You've got these incredibly powerful models, right? But they aren't built to just remember things. Every single time you ask them a question, they are basically recalculating the answer from scratch. It's all brute force computation. So here's how we're going to break it all down. First, we'll talk about this brute force problem. Then, we'll get into the big new idea, adding memory as a new axis for growth. We'll meet the tech that makes it happen, this thing called Engram. Then we'll look at the balancing act between computing and just looking things up. And finally, we get to the really juicy part, the totally unexpected boost in reasoning and what it all means for the future. Okay, so let's set the stage here. The core issue with today's large language models is what we can call the brute force problem. The way these models, like transformers, work is through something called conditional computation. Now, what does that mean? Well, think of it like this. To tell you that Paris is the capital of France, the model doesn't have a little file that says France capital Paris. No, it performs this incredibly complex series of calculations across trillions of parameters to figure out that the most probable answer is Paris. It works, obviously, but it's kind of like using a supercomputer to solve 2 plus 2 every single time. Super inefficient. Now, the best solution we've had for this so far is a technique called mixture of experts, or MOE for short. It's a really clever trick, actually. You have different specialized parts of the model, the so-called experts, and you only turn on the ones you need for a specific task. It lets you build bigger, more efficient models, for sure. But here's the catch. It's still just a smarter way to compute. It's not a memory system. And that, right there, brings us to the big, game-changing idea in this paper. What if, instead of just trying to make computation more and more efficient, we added a completely new dimension for these models to get smarter? What if we just gave them a memory?
And that is exactly what these researchers are proposing. They call it conditional memory. Now, the key phrase to pay attention to here is O1 lookup. For anyone not deep into computer science, that just means an action that takes the same amount of time no matter how huge your database is. In other words, it's instant, perfect recall.
This quote from the paper itself just nails it. It perfectly captures the problem they're trying to solve. For all this time, we've been forcing our AIs to do something they just weren't built for, faking a memory with pure math.
So how did they do it? How do you actually build a memory for an AI? Well, they created a special module, and they called it Engram. You can really think of Engram as the AI's ultimate cheat sheet. So when the main model sees a common phrase or a simple fact, like a famous quote or a capital city, it doesn't have to think about it at all. Engram just steps in, instantly looks it up in its memory, and hands over the answer. This offloads all the easy, repetitive stuff, and that lets the main model save its brainpower for the really hard problems.
Okay, but this introduces a really fascinating new problem, right? If your AI can both compute and remember, how much of each should it do? What's the perfect balance? Well, it turns out there's actual math behind it. They discovered what they call a U-shaped scaling law that helps find the optimal trade-off. It's pretty cool. If you have too little memory, the model is still wasting energy computing everything. But if you have too much memory, you aren't leaving enough of the model's capacity for actual genuine reasoning. They found that sweet spot right in the middle of the U.
All right, and this is where the story gets really, really interesting. So they built this system to be better at remembering facts. And guess what? It worked. But that wasn't the big story. Not even close. Something else happened. Something way more profound.
This is the crucial takeaway. The biggest improvements they saw weren't on knowledge-based tests, which is what everyone would have predicted. No, the model started making these huge leaps in tasks that require complex, multi-step reasoning. It's like they gave the AI a dictionary and all of a sudden it got better at philosophy. It's just wild. Just look at this. On a benchmark called Big Bench Hard, which is specifically designed to push the limits of an AI's general reasoning, it jumped a full 5 points over a comparable model. In this field, that is a massive, massive leap. And it didn't stop there. On Arc Challenge, which is full of tricky science questions that stump most models, it saw another huge gain, almost 4 points.
It even became a better programmer. It got a 3-point bump on the human eval benchmark for writing code.
And it got significantly better at solving complex math problems. It wasn't just remembering formulas. It was getting better at actually applying them to solve problems. I mean, this table just lays it all out. It's incredible. You can see the knowledge gains it was designed for down there at the MLU benchmarks, and they're good for sure. But then look at the top of the list: general reasoning, science questions, coding, math. The gains in these thinking-heavy areas are consistently bigger. It's just undeniable. Giving the AI a memory made it a better think. So the big question is, why? Why did this happen? Well, the researchers dug in, and their analysis suggests that by letting Engram handle all the simple, boring recall tasks, it freed up the early layers of the neural network. This basically let the later, more powerful layers of the model specialize in what they're truly good at: abstract reasoning. So the model didn't just get wider, it effectively got deeper for problem solving.
Oh, and as if that wasn't enough, there was another awesome bonus. By offloading a bunch of stuff to the memory module, it also freed up the model's attention. This made it dramatically better at long context tasks. You know, the classic needle in a haystack test where you have to find one sentence in a huge document. Yeah, it jumped from a solid 84 to a near-perfect 97.
So let's zoom out. What's the really big takeaway here? What does this all mean for where AI is headed? Well, the researchers argue that this isn't just some minor tweak. They see conditional memory as a totally new and fundamental building block for the next generation of AI. It's the key to building what are called sparse models. These are models that are smart enough to only use the exact parts of their brain they need for any given task. It's a way to make them both incredibly powerful and incredibly efficient by intelligently blending computation and memory.
And that really leaves us with a final, pretty mind-bending thought. For years, we've basically been scaling AI along just one axis: more computation, more brute force. This research opens up a second, totally complementary axis: more memory. And it just makes you wonder, what becomes possible when an AI can do both, when it can reason like a genius and remember like a library? That's a future that looks very different,